Okay, so we're going to go get started. Let's go get started with 6.2. And we're talking about dot product of vectors. 6.2. Dot product of vectors. So this is something you guys have never seen before. It's brand new, all right? So dot product is defined as a UV like this. So if I have a vector, let's say V is V1, V2, and U vector is U1, U2, the dot product is defined as we multiply the x's together, U1, V1 plus U2, V2. Okay, so this is brand new. All right, so that's on page 467. It's a middle blue box, the definition of the dot product. So when we do it this way, if you go ahead and switch this and go V dot U, it's the same thing, right? Because I'm going to take the x of the V, which is U1, and then the x of the U, which is U1. So it becomes a V1U1 plus V2U2, which, as you can see, are the same. In other words, I can say that the V dot U is equal to the U dot V. And that is on page 467. That is a property number 1 there. Okay, property number 1. Okay, the second one is, let's do property number 2. Property number 2 says if I do U dot U, I'm going to take this guy and then multiply it by this guy right here. So it's going to be U1 times U1 plus the Y, which is U2, U2, which happens to be U1 squared, U2 squared, which we all know is the square of the magnitude. Because the magnitude, remember, the magnitude was what? The magnitude of U1 here, the magnitude of U is U1 squared plus U2 squared. So this guy here is this guy here squared, like that, okay? And that is property number 2. Property number 3 is pretty simple, because if I have a 0 dot U anything, right? Anything times 0, 0, is I get 0 and 0, it's just going to be 0, all right? 4 and 5 are pretty self-explanatory. I'm not going to go over that. Read that, please. See if you understand that. Okay? So let's go ahead and do example number 1. Let's do example number 1. Example number 1, we have find the dot product of 3, 4, and 5, 2. 3, 4, and 5, 2, the dot product. Okay, so I'm going to multiply the x's together, 3 times 5, and I'm going to add the y's, multiplication of the y's together. 15 plus 8 is 23. As such, then we have B, 1 minus 2 and minus 4, 3. 1 minus 2, dot product of minus 4, 3. Again, 1 times a negative 4, negative 2 times 3, negative 10. Okay, one thing to realize is that when you do a dot product, you started with 2 vectors and you end up with something that's just a number. In other words, just a number meaning there is no direction here. So you have 2 vectors and you end up with a scalar product. Okay? So the dot product itself is always going to be a scalar. It's not a vector. Okay. C, 2 minus 2I minus j, 2I minus j, dot product, 3I minus 5. Obviously, these are all standard vectors here, okay? Now, realize that I'm using the regular brackets here because this is not in a vector form. It's not in our regular vector form, okay? So that's why it's not in the brackets, the different brackets, okay? But it's the same thing. So we're going to take these two together. So it's going to be 2 times 3. And then I have -1 times -5. As such. So I get 6 plus 5 is 11. Okay? Example number 2. Use a dot product to find the length of the vector 4, -3. So in example number 2, they want us to find the length or the magnitude of vector 4 minus 3. So 4 minus 3. And the way we're going to do that was we're going to do the dot product onto itself. Okay, 4 times 4 is 16. That times that is 9 is 25. And remember, this was what? This was the magnitude squared. So the magnitude itself would be the square root of 25, which is 5. Okay? So that's example number 2. Okay, now we're going to talk about angle between the vectors. Angle between the vectors. So if I had 2 vectors, there is a way to calculate the angle using the dot product. Okay? And this is something that comes up quite often. This is a question that is one of my favorites on the exam. Okay, so take the dot product divided by the 2 magnitudes. All right, that's what we're going to do. So that gives me the cosine of the angle, which is the angle between u vector and the v vector. Okay. Okay. So let's jump right in. Put in example number 3. See if we can do this. Example number 3. Use the algebraic method to find the angle between u and v. Now they're giving us 2, 3, and -2, 5. 2, 3, -2, and 5. Okay, we'll just plug and chug, right? So the cosine theta is going to be the dot product, so it's 2 times -2, -4, plus 3 times 5 is 15. Okay? The magnitude here is what? Square root of 4 plus 9 times the square root of 4 plus 25. Okay, so I'm going to end up with 11 square root of 13 square root of 29. Okay? And if you do that, you're going to, and then how do you use this on your calculator? You're going to find the actual numerical value of this, all right? If you put it in your calculator, you're going to get what? It doesn't say in the book. All right. So you're basically going to use the what? You're going to use the arc cosine, right? The angle which gives you this value, right? The angle which gives you this value. So you go into your calculator and do the arc cosine to find out what the actual angle is. And that's how you would find the angle. Okay, the angle turns out to be 55.5 degrees. Okay, let's do B. Let's do the second one. And the second one, they're giving us, what do we have? 2, 1, and -1, -3. 2, 1, -1, -3. So let's see if we can do that one. We're going to have cosine theta 2 times negative 1, 1 times negative 3, then I have what? 4 plus 1, that's the magnitude of that guy. Now the magnitude of this guy would be 1, that squared, plus that squared, negative 5, root 5, root 10. Okay? So this, can everybody see that this is going to be, what's going to happen here? Negative 5 over root 5 root 10 is negative 5 root 50, negative 5 root 25 root 2. Root 25 is 5, cancels out, negative 1 over root 2. So the cosine theta is next. So this is cosine theta. Right. So this is a number that you should remember, right? What is the angle here? Anybody know what the angle is here? So we get cosine negative root 2 is going to be over here, right? Over here and over here. I mean, over here and over here, right? Because it's negative. So if we go here, what do we have? This is going to be what? This is going to be 3 pi over 4. Okay? The other one is going to be what? Just nothing more than negative 3 pi over 4, right? So it doesn't really matter. It's because it's 3 pi over 4. It doesn't matter which way we're going, right? The angle between the two vectors are going to be 3 pi over 4. Okay? So that's that. All right. Okay, orthogonal vectors. Go to page 469. There's a thing called orthogonal vectors there. Orthogonal means that the angle between the two are 90 degrees, and that's what we call orthogonal, okay, 90 degrees. You have learned it in geometry or in other things as a different name. So orthogonal is what? Orthogonal is the same as perpendicular, right? Perpendicular? Perpendicular, okay. It's a perpendicular line. When you go to calculus, you'll learn this in another name. Another name is called normal. Okay, these are all mean the same thing. They are 90 degrees, okay? Okay. When you have a 90-degree vector, okay, the dot product is 0. Okay, and that's what they're telling you there on page 469, the definition, the blue box definition. Okay, let's see what we can do with that. So let's go to example number 4. Example number 4. Prove that the vectors u and v are orthogonal, where we have u is 2, 3, v is equal to negative 6 and 4, negative 6 and 4. So if I do u dot v, I'm going to get what? 2 times that, which is negative 12, plus 3 times 4, which is 12. Lo and behold, it is 0, which means that it is orthogonal. They are 90 degrees. So if you actually drew this, you would have what? 2 and 3, 2 and 3. Then over here you're going to have negative 6 and 4. So basically this vector, these two vectors, what it's saying is that is 90 degrees. Okay, the angle between each other are 90 degrees. They are orthogonal. In other words, perpendicular. Okay? And we're going to call it a day right here, okay? Any questions that I can answer right off the bat that you guys might have? No? Okay, so everybody understands that on Friday we have a test, correct?